Okay, so let's continue and let's rewrite everything here once more. So we have v of t is equal to, I'll just write acceleration as force over mass again, just so it's more consistent, times time plus the initial velocity. That's a bit to the top. Plus the initial velocity. Okay, now let's rewrite v as a derivative of x. So d of x divided by, or with respect to time, is equal to the force, constant force divided by mass, t, and then we'll add the initial velocity once more. Now let's multiply both sides by dt so it cancels out here. So d of x is, we get the constant force divided by mass times t plus, sometimes you confuse t and plus, so I'm just curving the bottom, plus the initial velocity times d of x, sorry, dt, not x, dt. Now let's divide, let's take the integral from x sub 0 to some x sub t, right? So x sub t, so sometime t, the total position of d of x. And when you take the integral of a derivative, this will cancel out, and this is, we're left with the integral of what? It's the integral of time 0 to time t of F over m, so the force divided by mass, t. This could be written as, honestly, I could just put the t up here, but it's whatever. Dt. And now to this, let's put this in a bracket real quick. Do it in an easier way. To this, we'll add the integral of v. Let me just fix that. We'll add the integral from 0 to t of v. Remember, this is just some number. This is a constant. It's going to be a value. It's a velocity. It's a number. dt. And again, remember, like we did last time, if it's a number, then you just multiply these two. You'll just be left with vt. But then we have to evaluate from here to time t. So now, here we'll be left with, if we sub into x, we'll be left with x t minus x, the initial x, I don't know why I wrote it like that, the initial x is equal to, now taking the integral here, we'll just move f over m to the front. We'll be left with the integral from 0 to t of t dt, and this over here will just be this will just be squared over 2, right? That's what we'll be left with. And we'll evaluate that from 0 to t. So let's put the, let's put, just so we separate. Over here we're left with plus the initial velocity times time evaluated from 0 to some t. Alright, looks good. And we'll keep this side like it is for a bit, just so we could get done with the other side, and that way it's a bit easier, Okay, so what we're gonna do is, since we've evaluated this, we know what it is. We're gonna just keep this f over m here, so we understand better. Fm, and we multiply this side by, not multiply, we square it and divide it by 2. And then so t squared divided by 2. That's what we get over here. And now we add, and since v initial sub t is just v initial sub t minus v initial times 0, which is just 0. So we'll just get v initial sub t over here on this side. And over here, the only thing we have to do to get the total position is just multiply, or sorry, not multiply, just move this to the right hand side, and we'll get m, and now we could do, 2m and t squared plus the initial velocity t plus the initial position, and we're done.